Okay, in today's lesson, I introduced the students to exponents and powers of 10. So first, I started off by just explaining what an exponent does. So if we take the example of 3 to the 4th power, then what this means is 3 times itself 4 times. So we're going to go 3 times 3 times 3 times 3. Now this is not to be confused with 3 times 4, which would be 3 plus 3 plus 3 plus 3, which would equal 12. But 3 to the 4th power is 3 times 3, so we have to multiply that, and that'll be 9, and then 9 times 3, which is 27, and then 27 times 3, which is 81. So once the students understand the basics of what an exponent is and how it works, then we're going to apply it to powers of 10. So if we take 10 to the 2nd power, that would be 10 times 10, which equals 100. If we take 10 to the 3rd power, that equals 10 times 10 times 10, which equals 1,000. If we take 10 to the 4th power, that would be 10 times 10 times 10 times 10, which equals 10,000. Now at this point, I asked the students to see if they can recognize a pattern and therefore a shortcut we can take without having to write out the factors before figuring out that it's what the total is. And after some discussion, some were able to figure out that we have, if we have 10 to the 2nd power, the exponent tells us how many zeros are going to follow the 1. So we have a 1 with 2 zeros. If we have 10 to the 3rd power, we have a 1 with 3 zeros. If we have 10 to the 4th power, we have a 1 with 4 zeros. And so they should be able to do 10 to the 7th power easily and not having to write out the factorization of it, and just go straight to the 1 with 7 zeros. 1, 2, 3, 4, 5, 6, 7. So in tonight's assignment, they're going to write the following in exponential form. So I have a 1 with 3 zeros, so that would be 10 to the 3rd power. I have 3 zeros, so I'm going to have a power of 3 to the 10, 10 to the power of 3. Here we have 10 times 10, which is 10 to the 2nd power. Here I have a 1 with 5 zeros, so that's going to be, you guessed it, 10 to the 5th power. All right, now here I have 10 times 100 times 10. We would say 1 times 1 is 1. And then we have 1, 2, 3 total zeros, so we're going to have 3 zeros, which equals 10 to the 3rd power. Here again we have 1 with 1, 2, 3, 4, 5, 6 zeros, that's 10 to the 6th power. And here we have, going back to this problem here, if we have a 1 here and a 1 here, we know that's going to turn out to be 1. So all we really have to do is count the zeros in our factors, and we're going to get our answer. So here I have another 1 and a 1, which is going to be 1. So I just count the total number of zeros. 1, 2, 3, 4, 5 because that's what I'm going to end up with anyway. So I'll have 10 to the 5th power. Now the purpose of introducing exponents already, but specifically with powers of 10, is because it's going to help the students understand the place value system in a base 10 number system. So for example, if we have a 4 and we're going to multiply it by 10 to the 3rd power, you want to initially convert that into what 10 to the 3rd power equals. So we would say 10 to the 3rd power equals 1,000. And then we have the problem, which is simpler to understand. We can do 4 times 1,000, which is 4,000. Now I taught the students 2 ways to do this. One is by simply multiplying the first digit with the first digit in the second number with the zeros, and then we have 4 times 1, which is 4, and then 3 zeros, 1, 2, 3. Now this method is indeed simple, but it is also limited when we get to situations where we have decimals. The other way, the other strategy I'm teaching the students is to use a place value chart, which they can make pretty simply just by making a quick place value chart. So we're going to do it like this. We're going to go like this, and then we'll have this be the ones place here. And then we're going to multiply the 4 by 1,000. Now, if we multiply the 4 by 1,000, the students have already learned that the digit shifts to the left 3 spaces. So we're going to go 1, 2, 3. So it would equal that, and then we would put in the placeholders, one for the hundreds, the tens, and the zeros. And you can see we end up with 4,000. I'm going to stick from now on with the chart, so I'm going to make another chart for this problem. 1, 2, 3, 4. Okay, so I'm going to put 64, so I'm going to put the 4 in the ones place and the 6 in the tens place. And I'm multiplying by 10 to the 4th power, so that's going to be 10,000. It's a 1 with 4 zeros. Now if I'm going to do that, that means these digits are going to shift 4 spaces now. So they're going to go, this 6 is going to go 1, 2, 3, 4. And the 4 is also going to move 4 spaces. And then I have zeros to fill in the empty place values. All right, so that means my total would be 640,000. Okay, for C, we're actually going to be dividing by a power of 10. Okay, now doing the zero method, it would look like this. 5,300 divided by 10 to the 2nd power, which is 100. What we would do is we'd take this right here, the 53, and divide it by 1, and that would equal 53. And then you would take the zeros in the dividend and subtract the number of zeros in the divisor. So 2 zeros minus 2 zeros is no zeros. So I'm left with not putting any zeros in my answer, so that would be my answer. So that is, seems like a straightforward, easy way to do it, but like I said, it gets tricky when decimals are involved, and that's when students have a tough time dealing dealing with this method. If we go back to the place value method, we can make our chart. And we're going to put 5,300. And this time we're going to divide by 100. And when we divide by 100, the students have learned that the digits aren't going to shift to the left because that would make them larger. If we're dividing by 100, the digits are going to get smaller. If you think about it, what is 300 divided by 100? Well, the answer would be 3. So that 3 would move over to the ones place. And notice that it moves 2 spaces over. And the 5 would also move 2 spaces over. So we end up with 53. Okay, let's go ahead and do it with the next one. So we have 0, 0, 0, 0, 0, 0, 5, 3. All right, and we're going to divide this by 1,000. So 1,000 would be 3 spaces, a 3-space shift, and we're going to be moving it to the right since we're dividing it by 1,000. So each digit is going to move 3 spaces. So we're going to go 5 once, twice, 3 times over here, and the 3 moves over also 3 times. 1, 2, 3 right here. And then we 0, 0, 0. Like that. So our answer ends up being 53,000. Now, one helpful thing that the exponent does is that there's actually another connection that the students can make if they catch on. And that is if we are, for example, multiplying by a power of 10, and we're multiplying by 1,000. If by chance the student forgets that 1,000 is 3 spaces over, they have another reminder in the exponent itself. If we multiply by this power of 10, we're moving 3 spaces over. Well, our exponent is also a 3. So that's a nice coincidence. Same here, if we're doing 64 by 10 to the power of 4. 10 to the power of 4 is 10,000. That would mean that these digits move over 4 spaces. But the exponent is also 4. So whatever the amount of spaces that they're going to shift, it's going to be the same as the exponent in the power of 10. Looking here at dividing by powers of 10, the same is true, only you're shifting the other way. So here we have 5,300 divided by 100. We know that the digits shift over 2 spaces. Our exponent is also 2. So here we can tell that when we divide 5,300,000 by 1,000, or 10 to the power of 3, I know that the digits are going to shift 3 spaces because that's what my exponent says. So another coinky-dink. Now I said earlier that one reason I think it's better to use the place value system rather than that easy zero system is because when we get to decimals, it can be confusing for the students because some students will run into this error. So if we have this problem, which is 6 and 72 thousandths times 10 to the third power, well, that's 6 and 72 thousandths times 1,000. What students, a common error that students do is they'll say it equals 6.072, and then they'll put 3 zeros on the end, which, as you know, it just ends up being an equivalent fraction. I mean, equivalent decimal. And this happens a lot. So to avoid that error, if you're using the place value system, you can't make that error. So let's just do this and I'll show you what I mean. So we're going to have place value chart, and we're going to put in our digits. We got 2, 7, 0. Here's our decimal, and 6. So if we're multiplying by 10 to the third power, now you know that shortcut that we're going to be shifting 3 spaces because my exponent is 3. So each of these digits is going to move, since we're multiplying, it's going to move to the left. So we're going to move the 6, 1, 2, 3 spaces this way. Then the 0 right next to it, the 7 right next to that, and the 2 right next to that. The decimal, it's important that the decimal does not shift because it's the values that are changing when we multiply. And if we move the decimal with it, then the value didn't change. So we're going to keep the decimal. It's the place value that's shifting for these digits. So our answer becomes 6,072.